Alright, how's it going? This is Mr. Brewer again. I cleaned my webcam. I noticed the screen was a little bit blurry, so I took some alcohol rub with a little Kleenex and cleaned it, and now I can see that the picture is a lot better. So if you notice, I'm in the classroom now. I just got all you guys' packets in. Hope you guys are doing well at home. Miss seeing y'all in person. It's weird being in an empty classroom right now. I've moved the operation to the classroom because, frankly, I just don't like working in my bedroom. Alright, so here we go. This is the next section. This is solving rational equations. There's no easy way to do these, no like clear cut, cut and paste way. The main thing though is just that you want to get find a least common denominator. So basically you want your bases to be the same. Once you can do that, then you can essentially just cancel out the base, and I'll show you why in a second. So let's start with this first one. This has got a fraction in it, so you can go ahead and read these on your own time. I'm just going to go over to the first one. So I'm going to write this as 10 over x plus 3 plus 10 over 3, and then I'll write 6. I'll write that as 18/3. Okay, I'm doing that so that I can subtract this fraction here. So let me subtract the fraction. This will give me 10 over x plus 3 is equal to 18 minus 10. That's 8/3. Alright, and then since I want to get a common base here, this side has x plus 3 and this side has a 3 on the bottom. So what I'll do is I'm just going to cross multiply. So I'm going to multiply this whole side by 3 over 3, and I'll multiply this whole side by x plus 3 over x plus 3. What that allows me to do is have the same base, just like that. So now I've got the same base, and once you have the same base, that actually just it basically goes into oblivion. Why? Because I can multiply both sides of the equation, the numerators, by 3 times x plus 3. And when you do that, the top and bottom, the 3 times x plus 3, all that will just cancel out. So, moving up here, what you have is 30 equals 8 times x plus 3. And we'll just solve for x here, so I'm going to distribute the 8. So I get 30 equals 8x plus 24, minus the 24 is 6 equals 8x, divide by 8, x equals 3/4, and then put that in for your answer. And it's always important to check this. So it says here underlined, always check to make sure your answers do not result in an undefined answer. In other words, if I plug this in for x, is that going to give me a 0 in my denominator? Well, the short of it in this one is no, because 3/4 plus 3 is not 0. Alright, so let's go ahead and move on to the next one. This one, I don't have to deal with adding or subtracting weird fractions. This side has 5, this side has 5x. So the left side is missing x. So I'll just multiply the top and bottom over here by x. It's a perfectly legal move. Why is it legal? Well, x over x is just 1, so it's like you're multiplying by 1. And why am I doing this? I'm trying to get 5x on the bottom of the left side here. So this will give me 2x squared over 5x equals x squared minus 5x over 5x. And look, now I have the same base. So those just, they go away. So I'm left with 2x squared equals x squared minus 5x. I'll subtract the x squared. That gives me, that's going to give, I'm just going to move both, I'll move both these terms to the left side. So set it equal to 0. So I'm going to get x squared plus 5x equals 0. And then I'll factor out an x. X plus 5 equals 0. So I have two solutions here, x equals 0. And x equals negative 5. Why is that negative 5? Well, if you set x plus 5 equal to 0, solve for x, you get negative 5. Okay, so this is where you want to check your answers. So I have these two solutions. If I plug in -5, this is a -25 on the bottom, that's okay. Plug in 0 though, I would get 5 times 0, that would give me a 0 on the bottom. So x cannot equal 0, so I only have one solution here, x equals -5. Okay, I'll stop this video and make another one for the next page. Thanks.